I'm going to leave the volume on, guys, because I realize if someone calls me, the microphone shuts off mid-recording. So I'll just leave the volume on so if someone calls, I can fix it. All right. Done, 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 done. You got the plus C, right? Mm-hmm. Signs are all perfect? Yeah. Okay, good. Number next one. 38. B.
I mean, 40.
C.
That's it. Right? Yeah.
Any questions on odds?
No.
45, 57.
Okay, who wants it? Go to the board. Not Georgie, he's going to work.
I think I have
45, Amanda took it. 57.
I didn't get to that.
Okay, 57. 41 as well.
Oh, 41? I got that one.
Okay, 41, Joy to go.
Are we supposed to be doing this homework?
Do something productive.
Yeah.
Only until class starts. Well, it did start. You know what I mean.
Yeah, I know. We do know this, right?
Yeah.
Little tray, right?
Yeah. Amanda, show me what you have for 57.
Alright.
Alright.
That's pretty good.
I found a black cat, and that's all I'm picking up.
Your face right now. I don't even need a lot of room, don't worry.
You're doing 41, right?
Yes, you are.
Oh, I did it wrong. Never mind. Because I thought I was doing this one.
You finished these, right? This one should be fast because you're just doing multiple.
I think that was
Oh, sorry, Joyce. I'll pause the recording. They're just doing problems on the board. You can see it when you get in, so I'll take pictures.
We're back, Joyce.
Okay.
Hey, Joy.
Oh, hi, Jackie. I didn't realize you were sick the first time. Or absent. We're trying to solve, so we're in our notes now, and then Amanda's group chatting all the things that we did, and it took us a little while to figure out 57 and 45. 57, my bad, trig property, secant squared equals 1 plus tangent squared, and then 45, it was tricky. Integrating the first one. Potatoes were integrating while I was working on the problem, so therefore on the, what did you guys get in the final?
Y equals square root of -2 9 x cubed. Or 3y squared equals.
Oh, okay, what's that? 3y squared?
3y squared equals, or 3 half y squared equals -1/3 x cubed.
So if we were to solve, we could multiply both sides by 2/3 and then square root. Is that what's going on? So y is equal to 2/3. That'd be -2 9 x cubed. The plus c is just going to be a plus c and then square root in. Is that good?
Can I leave this the plus on the outside?
No. Because when you square root the y, the c is now chopped in.
You're gonna kill puppy.
Poor little puppies. And technically we could say plus or minus depending on the context, right? Because y squared could be a positive or a negative. Alright, that was the first one. Second one?
Y with absolute value sign as.
Negative though, right? Oh no, you're right. L inside. L inside. So x. Let's see. He's good?
Yeah.
Number 3.
Absolute ln of absolute value of x is the integral of 1 over x, right? Yeah. Just the last one. And when you make u e to the y plus 1, you get the derivative of e to the y, and then or e to the y dy dx. And then you kill yourself.
Why not integration on clock?
Because you don't want dy dx.
Hold on.
Do dy dx. No, they give you dy dx. Oh,
So if you're doing u sub,
You can solve for it, but then you're also going to have another e to the y, and you have to get a Wait, e to the remember it's just dy, not dy dx?
the x is 1.
But the derivative of y is dy dx.
Remember, it's du dy, and the dy goes to the other side.
Oh, okay, that's
There
why.
you go.
That's why.
Yeah, that's why you get confused. Because then we just have 1 over e to the y du. But hold on, who is e to the y? But how do we integrate that? It's like there's two separate pieces and they're all together in one part.
No, u squared minus u. 1 of u squared minus u, and then make it a negative 1.
A good idea. We just haven't covered this much. So you're still getting
Oh, yes.
partial fraction.
Yeah.
U is e to the e to the y plus 1, which is e to the y.
So then 1 and
I know. I plugged in.
How'd you get e to the negative?
Well, because I had an e to the y right here and I changed e to the y to e minus 1.
just 1
I have it again. I thought that was a u to the negative 1.
Oh my gosh.
So then I cover up. Do you guys remember how the cover up trick works?
Yeah.
Okay, ready? Cover is 0 is 0. So plug in 0. 1 over negative 1. Key gets a negative 1. And then cover up 1. 1 over 1 is.
Yeah, I have a problem. My fingers cover up the whole problem. I can't do thumb roll, pinky roll.
See, my problem is that the protection keeps shining even though my hand covers, but oh well, you just make do. Ellen, what do we have? Who's you? You to the y. Plus 1. Boop. Plus ln of e to the y plus 1 minus 1 equals 2 ln of x plus c.
Just you gotta remember how to do third.
I just did it.
You did it.
I was fine.
Okay, look. You cover a factor and you plug in his 0. So his 0 is 0. 1 over 0 minus 1 is negative 1. So he gets a negative 1. And you cover, his 0 is 1. 1 over 1, he gets a 1. Well, when we do partial fraction, plug in the 0, the factor you're covering, and then after you solve, that's the coefficient that goes on top of that factor.
Do you plug the 0 into the everything else?
Yes. Well, not the TV, but because we're taking this algebraic. Stink-a-dink,
Can you plus or minus get rid of the abs?
that just goes away, right?
Yeah.
Well, I would do probably instead
Oh, nice.
quotient property, right?
Yeah.
And then how do I get rid of ln?
Math magic.
I can do e. And then you get e to the y over e to the y plus 1 equals. Help us out real quick. What's going on over here?
X squared plus C.
Yeah, I can
Oh,
make
no,
that a
C
squared.
to the X squared.
I can make this e to the ln of x squared times e to the c. And e to the c is a new arbitrary constant c because it's just a number to a number. So I can just say c e to the ln of x squared, e to the ln cancels. I just have c x squared. Whew, that just got a whole other level of fun.
And then we're done. We can't really do any simplification.
Because then at that point, you'd have to go ahead and get the e to the y's isolated, which you could do. You would have e to the y equals cx squared e to the y plus cx squared.
How come the back goes away out of curiosity?
Then you would, because x is always positive. And you have a c, an arbitrary constant that could be positive or negative, so technically it allows for both options of absolute value.
She's always positive, what's the
No. X squared is always positive, and c can be positive or negative, which means he allows for both the positive or negative as to what was inside the absolute value.
Well, you can rewrite after my like just do it.
Plus or minus c, and then it's a new other shape. And then I get everything to one side, I'd back drop my little e, and I would have 1 plus cx squared equals cx squared, and then I would have e to the y equals cx squared over 1 plus cx squared, and then I would do ln of both sides.
This is so complicated.
You think that's
Yes.
I haven't seen one quite this bad, I don't think.
Well,
But
like, not this bad.
the one where you have to use like
ln, you have to like get the e's and then you have to read ln.
And the whole like CE,
Yeah.
that or
Like, they
yeah,
definitely do
that one's. All right, whew, we made it. It was a little rough, but there we go. Oh man, that was the first slide. All right, so
what's the long story short when you have a differential equation if you need to solve it?
Separate it.
Separate it, but how do you separate it?
So you have y ln x minus dy dx, or x dy dx.
You need to think of, can I say everything positive? Is that okay?
Yeah.
You need to think of your y prime as dy dx, right?
Yeah, and so 1 over y, ln x over x.
And the only way that we can integrate is if we get everything on one side in the sense of, in terms of. Now remember, in order to have the differentials in the proper placement, you're never going to be dividing by a differential, you're only going to be multiplying by a differential, right? So I leave the dy, I need to multiply up the dx, that way they're ready, they're waiting for an integral, but they need some other people. Like, this one already has an ln x, he's staying because he's going to go with dx, this x needs to divide to the other side, and this y needs to divide over here. Now it's all set up with separation of variables.
What if we can't separate? Then it's not integrable.
That'd be one of those like the AP a couple years ago with the plus or minus, like x plus y. They must not be asking you to solve for the original. They might just be asking you to use it. Does that make sense? Yeah.
I got y equals x over x. Come on. Y dy equals x over
Yeah, it shouldn't be y dy, you have to divide the y. So it's dy over y or 1 over y dy. Y is on the other side. We're not going to subtract and divide both sides by anyway. You divide by y to get it over.
Oh, wait.
Multiplication is undone by division.
No, I divided that on. What?
But you need to get only in terms of y on one side.
So I did y ln of x equals x dy dx multiplied to d.
I think you have to have the
You
1
1 over dx and 1 over dy.
Yeah, so you need to flip everything because you need to. That's what I meant by you need the dy dx out of denominators. Otherwise, it's illegal for us to do. Does that make sense?
Oh, I multiplied dx and I thought it was d.
Okay.
I'm just a d dork.
There you go. Oh, that as well. Oh no! We need integration by parts on the right, right? No, because what would we set u to be?
ln of x.
What's du?
1 over x and then multiply the x and then.
Perfect.
x
And
over
that
x.
matches up, right? Times x times x.
Did you get ln squared x?
Yeah, 1/2 ln squared of x. Let's see. We have ln of y. Well, kids, we're getting ready for exponential growth and decay, but this section literally starts in separable differential equations. So if you want, you can play around with differential equations this weekend and save the applications for Monday. Is that good? Just start.
Yeah, you said that in your group chat.
Got it. All right, cool kids. Thanks for hanging in there. We had 2 fun ones today, huh?
Joyce, if you really thought this was like completely hard, leave a dislike, subscribe, and a very
really?
mean comment in the description below.
Oh,
What about
Jackie,
Jackie?
you're free.
Jackie, you too. I'm sorry. I just said you said just saying Joyce.
have a good weekend, everybody.
Oh.
What?
I have the SAT tomorrow, so it's not gonna be that fun.